So, okay, so today's Wednesday. It means that our today's topic is about responses, um, system responses. And again, let's take a look at the questions I have. All right, so there is the determine again the system coefficients or system parameters for A and B for the system. I think this one has something different. Yes, it actually has a little bit of difference from the yesterday. And then uh, stem plot the first 12 values of the impulse response and determine if the system is IIR, meaning infinite impulse response, or FIR, which is finite impulse response system. And then plot the frequency response at given sample rate, and then does the system linear or nonlinear phase response. Then again, plot zeros and poles on Argand's diagram. Plot the group delay of the system. Ha! Then scale the system such that it has unity gain at passband. And then there's again random noise with given some this signal to noise ratio for that kind of signal, calculating the spectrum and plotting the spectrum and filtering. First part of filtering. But anyways, let's me first go through briefly what this all is about. So the key element for any response is basically that you have the system description. That was yesterday's topic, was the transfer function, how to define transfer function or the system coefficients that you should know by now. And basically, for any response in digital domain would start from, is that delta? No, that is not delta. This is delta. Okay. Delta input, which would give me impulse response output. So that is actually the definition of impulse response. So basically, you just test the system with the impulse, and that's it. Or, hey, welcome. In case you have an analog system and would like to actually, test it on digital domain kind of thing, then you would do step response by running the unit step input the system. So basically, well, function generator gives this nice edge that you can use. Oh boy, neither of this is actually good. So you will run the edge and actually use the formula that you get the impulse response when you do the first order difference filter or high-pass filter for the step response. And then you have the impulse response. Okay. Yesterday you also, well, you knew it already, but I basically just told you so that the Z transform of the impulse response is the same as transfer function. And basically, when you put the Z equals to e to j omega, meaning you are evaluating the transfer function on the unit circle, that is the same as same as Uh, frequency response. Okay, there this omega is the so-called angular frequency, and there is a definition for that. So you can calculate the angular frequency by formula 2 pi times the frequency divided by the sample rate of the system. So this basically just linearly scales the physical frequency into unit circle, well, not unit, as an angle on the complex plane. Okay, so if you have a out of ink here. Let me see if I can pause the system, since I really would like to. It doesn't